Okay, continue on to chapter 3. We are getting into these things called logic operators. First thing I want to talk about is let's talk about something called Boolean logic. There's a guy back 1800s, name was Boolean, and he was working with electrical circuits. Basically, if this switch is on, this switch is off. How the electrical circuits go. He developed this thing called Boolean algebra. And basically, what he says is this. He says, if, let me just kind of write it out here. So, if I have something that looks like this, if A is greater than B, then basically do something. I could come down here and have an open brace, and I could then indent and say if C is greater than D, and it actually continued on. Now, what I could do is I could actually put those in one statement, and the way I would do it is this. Is I could put double parentheses, and I would put the word, or not, I wouldn't use the word and, what I would use is an ampersand. Then I would put an ending parenthesis. Now, if I use a single ampersand, that says, now let's talk about Boolean first. So here's what Boolean said. He says if we have the word and, in this case the ampersand, it says both of these statements must be true in order for the whole entire if statement to be considered true. So if A is not greater than B, and C is greater than D, so if this part is false and this part is true, the whole entire thing is considered false, because Boolean algebra says they both must be true in order for the whole thing to be true. Now, what we have in Java is a double ampersand. We like to use that. Now, here's what the double ampersand means. It says if that means an and statement, and according to Boolean algebra, they both have to be true for the whole thing to be true. Well, what it says is if this first statement is false, is there a need to even check the next statement? No, because if that one's false, the whole thing's considered false because they both have to be true. So the double ampersand says if this first one is false, there's no need to check the second one. Okay. If you have a single ampersand, this first one will be false. It will still check the second one. So double ampersand says I'm an and statement, but if the first one's false, no need to check the next one. Okay. So if we take a look at some examples, we have well, it's the logic and the logical and. So if we take a look at this, here we've got two double variables, and we got a string input, and we're using the J option pane dialog box, and we're getting the salary. We're converting that into a double parse. We're then getting the years on job. We're basically converting that to a double parse, and then we're saying, so do you remember the very first program, one of the very first programs we did for chapter 3? It says if the salary is greater than 30,000 and years and jobs greater than 2, you qualify for loan. Else, you do not qualify for loan. So now we've taken that multiple nested if statements and put it into two simple if-else statements. Okay. Now, if your salary is 28,000, it's less than 30, there's no need to even check the next one. In fact, it won't even check it, and it basically goes on from there. So there is our and, our logical and statement. So if we go ahead and run this, it basically comes up and there's the number of years. I'll say 2. You do not qualify loan because the first thing it checked was how much you make per year. So if I run this again, I qualify for the loan. Okay. Now, to go along with the AND statement, we also have the logical OR statement. Now, according to Boolean, going back to Boolean algebra, Boolean says if you have an OR statement, one or the other, or both, one of them just needs to be true. So in this case, I use the pipe symbol. Okay, the pipe symbol in Java is an OR. So in this case, if this statement is false and this is true, according to Boolean algebra, the entire thing is true because only one has to be true. The only time it's false is when they're both false. So one has to be true. Now, same as the ampersand, we have the double pipe. And the double pipe says, hey, if this first statement is true, there's no need to check anything else because the entire statement is true at that point. So there's no need to even check anything else. We're good to go. Let's move on. This actually saves some time in the programming during compile time and run time. So if we take a look at the logical OR program, same exact situation. If that's so, now what we're saying is all you need to do is be on the job 2 years, or you have to make $30,000. If one of those, so if you have either of those or one of those, you qualify for the loan. So if we run this, same exact thing. I'm going to type in my annual salary, $28,000. I'm going to type in 2. I qualify for the loan. So what we're saying is either one of those is going to get you a loan. Okay. So if this statement is true, no need to check the next one. It considers the whole thing true, and the only time it's going to be false is if both statements are false. So if I run this, I type in 28, 1, 2, 3. I type in a 1. I do not qualify for a loan. So they both have to be false for it not to basically go through. Now, if you look on page 141, it talks about the order of operation for ANDs and ORs. And the logical order of precedence, they call it, is it does a single OR first, then it does a logical AND, which is the two ampersands, and then the logical OR, which is the two OR statements together. So it's going to do, so when it does the check, so if we have an AND and an OR and an AND, it's going to basically check the single ORs first, then the double ANDs, and then go from there. Okay, last thing we're going to talk about is comparing string objects, and this is where it gets kind of tricky. So let me just kind of do a string compare here. So here I have my class is string compare. I've got my void main, which is my method, and I'm saying if name1. Now in this case, I'm not going to actually, because remember, as we talked about in previous chapters, strings are not primitives, meaning the actual field contains that data. They're relative variables, meaning it's pointing to some reference in memory. So in this case, if I used a double equal sign, they're probably not going to equal because it's looking at the relative address of those two variables. So those two variables could have the same exact data in them, but they're not truly equal. What we're going to use instead is the equals parameter of the string variable data type. Now remember, again, I can type in my variable name. So here's my name, which is a string, name1. I can actually, behind that period, I can do a control space, and there's all the different parameters that are available to me. You notice I've got equals, and it's got object, object, and it's going to basically return a Boolean, meaning it's going to return a true or a false. So it says if name1 dot equals name2 in parentheses, then it goes ahead and will print out something there. In this case, it says those two are the same. Else, it will say those two are not the same. So the dot equals, we really want to use that when we're comparing string data types. So if I go ahead and run this, it says Mark and Mark are the same, Mark and Mary are not the same. So in this case, I got name 1, name 2, name 3. So it's checking name 1 equal to name 2, which is Mark and Mark, and name 1 and 3, or name 1 and 2, name 1 and name 2, okay. And then name 1 and name 3, check to see if those two are the same, and they are not. And it basically will error out there. Okay. So the dot equals, primarily use that for string data types. Now if we take a look at the last thing in this chapter, which is the compare to, here you'll notice we have name 1 dot compare to, is it less than 0? So we use the compare to parameter, and basically what it says in the book, it says if the method's return value is negative, the string referenced by the comparing one to the other is less than the other object. So what it's saying is, when it's comparing the two, now realize when it's comparing, it's comparing character by character, length by length. And what it's saying is, first of all, if one's got a larger length than the other, then one is less than the other. If, let's say, for example, in the book, one of the comparisons they do is Mary and Mark. Well, the first letter is M, next letter is A, next letter is R, next letter is a K and a Y. Well, in the ASCII scale of things, a K is less than a Y. So that one string is actually less than the other. And so that's when we're going to get greater than or less than or equal to a 0. So in this case, it says, here we have, if name 1 dot compare to name 2 is less than a 0, that means they are not equal, or one is less than the other. Then that is less than name 2. Else if name 1 dot compare is equal to 0, then okay, so it kind of goes on from there. So one more thing I wanted to say about the double equal statement. The double equal statement is checking to see if two things are truly equal, and that means relative as far as in memory, are they equal. When we use the dot equals, that's just strictly looking at the value. So I look inside the actual variable to see what data is inside there, and I'm compared to the data inside the other variable, and that's truly looking at the inside, looking at the value itself. Okay, so here we have the dot compare. So again, if one's less than the other or equal to or whatever. So we got Mary and Mark again. So when I run this, it comes up and says Mary is greater than Mark. So basically this last statement was basically true at that point. Okay, the last thing I want to cover is when we're doing a compare to or equal to, one thing we can do is check to see if they equal but ignore the case. So again, in ASCII, a lowercase m and an uppercase M are two separate items. They are not equal. But if I want to, so again, if I'm dealing with what a user is typing on the screen, they do have a tendency to type in lowercase when I wanted them to type in uppercase. So in this case, I want to take what they type in and compare it to. So in this case, if they type in Prospero, but they typed in all lowercase, well, all I want to know is did they type in those letters, and I can actually say dot equals ignore case, and it will basically not compare uppercase and lowercase. It converts them all to either uppercase or lowercase and does a comparison of both strings. So if I run this and I type in again all lowercase, it says congratulations, you know the secret word. So it's looking at all uppercase, I typed all lowercase, and it works just fine. Okay, again, if you have any questions, make sure you email me, call me, text me. All my information's there, and we will see you next week when we get to the second half of chapter 3.